All right, well, I think we're going to start the webinar now. So good morning, good evening, depending where you are in the world. This webinar is on 4 productivity secrets about MRDCL. I've got Phil here with me, who's going to take you through the webinar. And at the end, what we'll do is a Q&A session. And Phil, I'll take any questions. There's a small box at the bottom of your screen, it's Q&A, and I'll be able to ask Phil your questions at the end. So I'll pass you over now to Phil.
Well, good morning, everyone, or good afternoon, as Charlotte said, if you're on the further east than maybe somewhere Eastern Europe. I can't remember now where the time zones end. We're going to do some productivity secrets today. So I'm hoping that what comes out of this webinar is that you find some things that you perhaps didn't know about, or perhaps some things that introduce you to some other ideas that you might not have thought of. I must first of all apologise. I've been fighting with my camera for the last 30 minutes and have unsuccessfully ended up here without being able to show my face on to you all, so I apologise for that. So let's make a start, just an introduction to the content of what we're going to see today. And I suppose what I'm going to try and get over in this session today is I'm going to give you perhaps to insight some of the power features of MRDCL. We're certainly not going to cover everything in this session, but what I always like to try and get out of these sessions is it's one of the things that we really promote when we're looking at trying to work with customers who use MRDCL, is to try and make them more productive, because we truly believe that MRDCL is the most productive software out there for doing cross tabulations. And so hopefully from this session today you're going to get some ideas on how you can be more productive, and perhaps give you some ideas on perhaps how you can take some shortcuts and improve the things that you do. So in this session, I'm going to do 4 different things. 2 of them are actually quite connected, so you might say it's only 3 things, so it should be perhaps 3 productivity secrets. But anyway, I'm sure you forgive me for that. I'm going to go through some topics. I'm not going to take questions after each part of the presentation, because there's a danger that that one section overruns and there won't be ample time for all the questions that different people might want to ask. So if you'd excuse me, I'm just going to go through the 4 topics one after the other, and there will be some time at the end then to post your questions. As Charlotte said, you can just post those and she'll coordinate those, and we'll get through as many as we can of those, and any that we don't have time we'll cover in separate emails after the event. So let's stop talking about what we're doing. Let's actually get on to doing something that we're really going to do today. So the first topic I'm going to cover today is, I've called it avoiding multiple runs. And what I mean by that is that I think it's very easy when you're working on a big project, particularly if it's a tracking study, a multi-country study, a project where maybe there's a short questionnaire and a long questionnaire, whatever it might be, it's very easy to proliferate runs. And it does seem like a good idea at the time to just copy and paste an STP file and amend the second one. But I want to just go through some things here which I'm sure some of you know already, but also just perhaps to go through perhaps the range of different tools you've got and techniques that you might adopt when you've got multiple runs. So we're going to work, as I often do in these sessions, with some fairly simple data. If I open up one of these files here, you'll see that I've got some pretty crude made up data here with 5 records in it, and I just want to walk you through what this data is, so that when we come to input some information in a minute, it'll all make a bit more sense to you. So we've got a serial number in the first 3 characters of this data. The 4th character I'm going to say is working status, and you can see we've got a couple of codes there. I think there's actually 3 codes across all the files. Similarly for age, we've got 3 age groups down here in the 5th field. In the 6th field, we've got region, which has 5 different codes. And in the 8th field here, I think there is a 7th field, I'm not sure what that's for, but in the 8th field, we've got a question, we'll just call it question 1 for now. And at this stage, I'm going to ignore all of the other data that is sort of to the right of that. So let's make a start on working on this data. And just as before I do that, you will have noted that I've got 4 data files here. So what I'm mocking up here is the fact that we've got 4 identical data files. For the ease of this demonstration, they all have the same file layout. The columns are the same in each file. But we've got a data file for China in 2017, a data file for China in 2018, and a data file similarly for USA in 2017 and 18. And each of these files have just got a handful of records in them. And what the task is here is to analyze them in different ways or different cuts, but essentially in one script. So I'm trying to avoid having 4 scripts that handle each of those files, or perhaps one file that handles China and one USA, so that what I can do is I can produce tables for China, USA, or the 2007 combined. And of course, in a bigger multi-country survey where maybe you've got 10 countries and 5 years data, you could expand this quite quickly to having 50 files in there. But again, for this demonstration, it'll just be the 2 countries for 2 years. So let's get in then to just putting in some very basic script very quickly, just so that you can follow through what I'm doing here. I'm going to call this run.stp, and I'm going to open that up so that I can actually put that script in. So let's just put these fairly straightforward definitions in that we talked about here. So let's put in, first of all, just do it for USA underscore 2017.asc. And I'm going to quickly just key in the basics of this script. So we can put in, for example, that we have working status was the first one, I think. Didn't take me long to miss a dollar out there. And I think we agreed that was on column 4, 1 to 3. And we can put in full-time, part-time, not working. So that's our first question. Our second question was age. '55 plus, so there's our age groups. Trying hard not to make a mistake this morning. We'll miss out region for a minute. You'll see why that is. I'm going to come back to that in a minute. And I think on the 8th field, we had question 1, which was, let's say that's a regular buyer, occasional buyer, non-buyer, and that's purchase of product X. All right, so we've got a very quick questionnaire together there with just 3 questions, and we could, if I could type properly, quickly set up 3 tables there, which are working status, but nothing for the moment, just a total only table, age, and table 3 will make question 1. So all very, very basic stuff so far. Now, just to make sure I haven't made a mistake there, let's run that. And sure enough, I've got some tables here, and these would be the USA tables from 2017, 3 records there, and I've got the data I would expect. Now, if I had more than 1 data file there, as I'm sure you know, you can just string these together, separating them by semicolon. So if I wanted to add in the 2018 data, I can just do that, and now I've got 6 records all combined together. And of course, I can extend that to a number of records there just by adding a list along there. One thing I can also do, which not everybody knows, is that I can put these list of data files into a text file. So I could say that my data files, and I have to use less than and greater than there, I could say that my data files are stored in a file called list.txt, which means that I can open up a file called list.txt. Oops, I've typed that wrongly, so let's just quickly correct that. Create that file, and in here I could put in my data files as a list, not with a comma on the end. And now I'm putting in all 4 files that I had originally, and now it should run my tables for me on 16 records. I think I've got 5 records in each of the China files, and I've now got 16 records. So that's a slightly more convenient way of storing that data. But what I can also do is I can store the data in the list of files in a CSV file, so that rather than, and I can do this in Excel, or I can just type in my own commas if I want to. So I can open up the run here. So now I can open up a CSV file. I could have done this in Excel, of course, and I can put in my own commas. And if I head the first, in the first row of this CSV file, the headers that I want, I can put in something that describes each of these data files. So the first field must be called data file. And in here, I'm going to put year and country, so that when I pick up the USA 2017 data, I can say that is 2017 data, it's country number 1, whereas the 2018 data is 2018, it's, still country number 1, and China 2017.ask relates to 2017, but it's country number 2, and finally that third file is like that. Now I could have done that in Excel. That will look just like a CSV file in Excel. I've typed it in here using an editor to type it in. Either is absolutely fine. But what I'm doing now, I'm actually assigning some values to variables in this CSV file. So what this will automatically do for me, with a little bit of adjustment to my STP file, it will automatically define a variable called year for me and a variable called country, such that those values 2017 and 2018 are assigned to the data automatically based on the data file. And that's obviously a very efficient way of working if you've got a multi-questionnaire version or multi-country or tracking type study. So let's save that. Let's go back into my script. Let's change that to data files.csv. Just quickly to check, I called it data files, not data file. I did. Okay. And now I want to be able to pick up those values from those data files. And the way I do that is to just dummy define at the top variables that match the headings in that CSV file that I just created. So you'll recall that I named those two. I named the first field data file, I named the next two year and country. So what I'm doing now, I'm just dummy defining those so that at the top here as integers, so that MRDCL will automatically encode that for me, which means then I can start to define variables down here. So I might define V country as coming from country 1 and 2, which is USA and China. And I could define the year as being year 2017. I could have obviously assigned 17 to that if I wanted to, and didn't put in a title there. And we can say that that is country, and we can now put in year as being X equal quote 2017, 2018. XT is year, and I can now define a banner maybe, which is, let's say, working age, and let's have let's do a variable here which puts the years within the countries. So we can say that the sample here is $V year dot by dot. Let's do it the other way around actually. V country dot by dot V year. Some of you may not have seen that before. So that's going to give me USA 2017, USA 2018, China 2017, and China 2018. Head that as sample. And now I could put sample on the end of my banner so that I can just type this in, and you might be noticing as I go along here some techniques that you don't know about for putting banners together. So I'm just plussing in the headings here. So I'm just taking in the labels and putting in my own headings and just taking the labels from how they were before. So there's my banner, and now if I've done everything correctly, I can say select banner is $banner, and hopefully all these tables, if I done everything correctly, are going to work, and I've had a good day today, obviously. And now I've got my 3 tables, which now have got working status across the top, age across the top, and that data that's come from the CSV file that's automatically been pulled in, the 3 USA records, the 3 2017 USA records, and the 3 USA 2018, and the 5 for the 2 years in China. So that was quite an effective way of managing the data files. But we can go on from there. Now, one of the things that I mentioned at the beginning, I don't like the idea of proliferating runs. So one of the things that becomes a problem with these types of things is, and you saw I jumped over the question region, because as you might expect, the region in the USA will be different from the regions in China. So I could, for example, here have 2 versions of that, but there will be a problem. So say in the USA there are 3 regions: West, Mid and East. Let's call it region. But in China there's 5 regions in the same fields, and I'm not an expert on China, so we're going to go north, east, south, west and central. I'm sure they aren't the categories that are usually used, but I can't do that because you'll know that if I try to compile this, and indeed, let me just do this so we can have something go wrong. If I compile it, I'll get an error because I'll get a faulty variable redefinition, because here I'm defining region as 3 codes, and I'm specifying region in China as 5 codes, so it's objecting to that. So I need some way to be able to say, well, when I'm running USA tables, I don't want the regions for the USA. I don't want for China. When I'm running China tables, I don't want the regions for USA. And we can start to control that by putting in a code at the top, which will control what run we're doing. So let's imagine here that we've got 5 different runs of tables we might want. We might want to run a set of tables for each of the countries within the years, in effect those 4 samples down here, and we might want a set of tables that puts all those together. So what I can do is I can say, well, let's have those 5 runs prepared, but let's skip round this. So skip 99 on run, and if we make these are the I picked the wrong one first, actually. I picked the 5 Chinese regions here. So I want to skip round these when we're doing runs 1, 2 and 5. So I want to say skip 99 on run is less than 3. And I also want to skip round it when run is greater than 4. So I only get that being picked up when I'm doing either of the China runs. And here I want to skip 99 on run is, so it's only when runs 1 and 2 for the 2 USA runs do I want to keep this variable. So I want to skip round this when it's greater than 2. Okay, so that should only allow that when I'm picking the run up. Now, how do I control which run I get? Because I can put in here a prompt that asks me what run I'm actually undertaking here. And then, of course, I want a title on my tables. So I might have a data statement in here which has the 5 titles. So we'll call this USA 2017, USA 2018, China 2017, China 2018 and total run. So they're my runs. So I can put in a heading now that percentage JH center is my project, and I pull in the title based on the country that I'm running. I'm just going to check I called that country. Yes, I called it country. So that's going to pull in the relevant title. So now let's try just putting in a filter so I only get my tables for the relevant. So unless sample is country, go to finish. Now that's not going to work when I pick country 5 because there isn't a 5th country. So actually I want to skip round this as well when it's the 5th run, because I don't want any filter when I'm doing all the countries together. So let's see how that works. So let's pick country 1 now, and I've done something wrong in line 23. So here we go. Skip 99. It's country equal to there. I got my runs and my countries mixed up, so I did wonder if I'd do that. So now I'm just getting my USA 2017 tables here with the correct title and just the 3 records that I want. Whereas if I pick country 2, I'm going to get the 2018 3 records. And let's just do a couple more runs. If I do, there we are, I get the 5 China records. And I'm hoping that if I do country 5, yes, I'm going to get all 16 records in here, which I do. So it seems to be that it's working now. And I might just add a couple more things in here. I could even add to the banner here that I want region except when it's run 5. So I could say skip 99 on country equal to 5. So that on the end here, I could say start, oops, I didn't put it in, $region, start 99. So this would add region to the end of the banner if we're doing any of the first runs. So I'm now going to say star skip 99 on country equal to 5 again, plus, put the heading in, region, backslash, plus dollar, I can't type this morning, region, star 99, comma. So now it will pull in region as well, except for the 5th run. So if we pick run 5, we don't get region on the end here, we just get the samples. Whereas hopefully if I pick run 1, I should get region coming out on the end. And if I look to the right, I've got the 3 regions coming out now. So what I'm doing here is I'm really automating things based on the run I'm doing and avoiding that temptation of copying and pasting so that that you get duplicate scripts. That it means if you make an error, you've got to go through and change them more than once in different scripts, and generally making the whole thing difficult to work with or increasing the workload that you have. Now, I don't particularly like this PP country prompt where I have to type in 1, 2, 3, 4, 5, because if I went back to this in 6 months' time, I might forget what that all meant. So a better way of doing that is to put in a data statement rather like this. So in fact, what I'm going to do here is I'm going to just actually grab this data statement called title here, move it to the top. And the reason I'm moving it to the top is then I can ask country here using the data statement title. So what that will do now is it will prompt me with a list of options. It's now given me a menu of things that I can do, and it'll behave in the same way as that prompt where it's asking me for a number. So if I click on China 2017, it'll go away and run the China 2017 tables for me, and there they are with their 5 records. So what this session has done is really just shown you how to handle multiple runs in one run. I'm not going to demonstrate that because of time constraints, but it's also, I think, if you have a project where you've got multiple runs, where perhaps I know people who do tracking studies where they want the last quarter's data, the last year's data, and the last 3 years' data combined. And what it's tempting to do is to keep having separate runs for these, even if the analysis is different. It's not an excuse really. You can control it all by skips. Build just one IDF with all of your records that you ever want to analyze in one group together, because when you get to the tables, you could, let's say you have a run that does 3 years data, 1 year's data, and 3 months data, and have 3 separate runs, and perhaps with different banners, different analysis. You can control all that with skip commands, and just have one IDF for the 3 years data, because MRDCL is very, very fast at just filtering out the records you want. So if you want a run that just picks out 3 months data from that 3 years, you can put an unless go to in the top of your table stage that says, unless it's the most recent 3 months, go to finish. And although the IDF contains the last 3 years data, it will very rapidly ignore the quarters that you don't want, and be a very efficient way of working. All right, so that completes that section, which is the longest section of the presentation today. We're going to move on now to looking at something quite different, but something I seem to be getting asked an awful lot recently, and that's reading Excel data. Now, it's something that sort of has gone from perhaps having just 1 or 2 requests to something that seems to be getting asked every month at the moment. And what we have here is a data file. It's in Excel, and I do get asked quite often whether we can read that data directly from Excel, and the answer is yes. So we've got a very simple survey here where we've got the serial number, gender, age, and a couple of questions. I don't know why Microsoft keeps wanting me to sign in today. And what I want to do is to read that data from Excel directly. Now, we do have a free utility that will read that data in and convert it to an ASCII file and give you a map, so that, for example, the serial number would be in the first 4 columns, gender would be in the 5th, age in the 6th, and that's one way of working. But there is a technique as well where you can work directly from an Excel file. So we're going to try and do that today. There is a video that actually goes through this in a bit more depth, but I'm just going to take you through the basics of what you can do. So we're going to call this readexcel.stp, and we're going to write some script that will read at least some of that file. I might not do all of it, I might just do a part of it. So we'll start in the usual way, start control, and a bit of a surprise now. I'm going to start with a file called dummy.asc. Now, why am I doing that? And I'm going to explain that now. And this is probably the most surprising bit of the whole thing. I'm opening up a file and I'm calling it dummy.asc, and I'm just putting in one line, and it has to be one line, of random data. Now, whoops, let's just close that. I've opened it twice. Here we go. So what's going to happen between here and here is that if I execute this run, and let's put in just one dummy variable, what it would do if I executed this now, and let's do it, why not do it? We run this, and you can see I've got one record in here and one record on my IDF, and that was that one record I typed in with 1s in it. Now, what usually happens, and this sounds remarkably obvious, is that when MRDCL runs, when it hits start data, it reads a record from the data file, dummy.asc, it reads that record. When it hits finish data, it writes that record away. And if there's a second record, it would read another record and write that away. When I'm reading Excel data, I'm going to cheat and not do that. I'm actually going to open up an Excel file and just read the lines in that Excel file and then finish data. And that's why I just want one record, because I'm actually just going to read that dummy record, and then I'm going to loop through my Excel spreadsheet and write away a record for each line in that spreadsheet. So let's put that into some practice now and make that sort of come to life a little bit. Now, when you use this technique, you need to dummy define all your variables. So you'll need to say that serial is dummy defined as serial. And if you want the variable gender, which was the second field, you're going to dummy define it here. So everything is going to be dummy defined. Age, I think, was an integer, so we'll dummy define age. And we'll just do one more field. Question 1, I think, had 2 responses. So it looks a bit different from a normal script because all I'm doing is doing dummy definitions with nothing else. Now to do the rest of the actual reading of that Excel file, we're going to have to use some EPS script to do that, and I'm not going to take you through the mechanics of how to learn EPS. If you want to learn EPS, there's 7 really good videos that take you through from concepts through to actually using it. But I'm just going to type these commands in and tell you what I'm doing, but without perhaps any more explanation than that. So I'm going to open up that XLSX file, and I'm going to give it the name DBXLS. That's just my name for it. I could call it any name I liked in there, but that's going to tell it to open up that file with the data in it. And I'm going to tell it to close that at the end as well, because it's good practice to close that. And now I want to tell it to loop round that XLS file. So if we open that up again, the worksheet is called data. So I'm going to tell it to loop round. So this is rather like writing a loop in the preprocessor that you might have seen do loops and for loops in MRDCL. This is a loop where it's not quite the same. It's going to tell it to start at the top of this spreadsheet here called data and finish at the end of it. So it's going to start in row 2 effectively, and it's going to end in row 19. So what I'm going to do now when I read this is I'm going to pick up each piece of the data as I go through. So I'm going to say set my serial equals db1.serial. So this is going to use the preprocessor or the EPS to put into an index called my serial the value as it reads down in that field there. So for the first time through this, it'll pick up 1, then 2, then 3, and then down to 18. So in other words, my 18 records. And I'm also going to tell it to set my my gender. And I could give this any name. I'm calling it my gender. It could be anything else, as the field called gender. You can actually call it here the same name. I could call this gender. I just think that can confuse people sometimes. That's why I'm putting my on the front to differentiate. You can have an index that's the same name as a column in the data. And I'm going to set my age as db1.age and set my q1 as db1.q1. So what that's doing is, as it reads down each line in this file, it's going to pick up these values in here in serial, gender, age, and Q1. Now I can actually push that into the data. So I can say that I want to redefine these variables that I've dummy defined at the top as the value that's in that index that I've picked up from the Excel spreadsheet. So I'm going to di serial equals my serial. I don't need to do anything else because we've given it a title up the top here. So that's all been done in the dummy definitions. For the gender, I need to make it. So I'm going to say make gender blank dot my gender. So it's actually going to make it with a make statement, which many will be familiar with. Age is an integer. So I'm going to define age equal to my age. And I'm going to finally make, sorry, Q1 blank and my Q1. So what this is doing is it's making the values for each line in that spreadsheet. Now I can write it away. I might want to define a variable in here, such as putting the age into some ranges. So I might say that vAge is age 16 to 34, 35 to 54, greater than 54. And we can say that 16 to 34, 35 to 54, and 55 plus xt is age. And because I've got a write statement, that one dummy record that you remember I put in at the beginning will not write away in the usual way, because the write statement, once there's a write statement, that will replace the finished data doing the writing for me. So that should write away my 18 lines in my file. And now I should be able to do some tables. I'm going to do age by gender, and I'm going to do Q1 by gender, just to make sure that everything's working. Let's hope it is. Let's run it. And sure enough, it's read my 18 records. It's gone through those 18 lines in my file, and it's produced me 2 pages of output, which look pretty good to me. I meant to tabulate V age there rather than age, but you can see I've just got the mean score. And here's question 1 by gender, and that looks as though it's correct. So what we've got there is a system in place for reading that Excel file. If you look at the listing file, it might look a bit more logical to you. So you can see here's my dummy definitions at the top. And then what it's doing, it's working through each line in that file. So there's my 4 definitions for the first serial number and my definition of age, and then it's writing it. Then we're going on to the second record. And so what it's doing, it's repeating all this code until we finally get down to the 18th record at the end. Here it is. So what it's doing, it's actually writing all this code out and writing away each record one at a time, so that when I get to my IDF, my tables run on 18 respondents. Now, that works perfectly well. You're not actually, some people ask me, how does that work with 5,000 or 10,000 records? Because the STP file will get quite long. Well, that's absolutely true. The code will get quite long, because the more records that you have, the listing file will just expand for each record. But it won't get big in terms of MRDCL processing, because it's actually only writing away the same number of variables. It's just in practice overwriting them. So that each time it goes through for each record, it's just overwriting the value and writing it away. So the record doesn't actually get big. The IDF is just like a normal IDF. It might take very slightly longer to run than a conventional ASCII file, but it's a very practical way of working. So that's an introduction to how you do it. You can step that up to another level. I'm not going to go through this here, but it's possible to have an EPS script that actually does everything for you here. So some people say that this gets a little bit boring to set up if you've got a lot of questions, because you've got to put all those dummy questions in. Actually, it's no more work than usual. But again, EPS can come in here, and you could set up something like this, which had a sort of control worksheet where you took the headings, copy, pasted, transposed them, told MRDCL what type of questions they were in a spreadsheet here, put your titles, say how many codes there are, say whether it's optional or not. And I won't explain that in this session, because that's another thing you have to take into account, whether codes are optional or not. And this piece of EPS then can read this control worksheet, so that you don't need to actually set anything up at all. Everything will get controlled by that, and that script I wrote with all my dummy definitions will automatically be generated for you. So here we have an EPS script, which I accept is quite complex, but there's no need for any of those texts in there. The text still need to go in, the titles still need to go in, although you could store those in a spreadsheet as well, and you could automate the whole thing. But that will do exactly the same job, just controlled by that sheet. And we've got a few more tables coming out now, as there's a few more variables. So that's a technique you can use. Some people question whether multis can be handled that way. They can indeed be handled that way. It's just just needs a way of pulling them together, because typically multis will be stored in a series of fields rather than one field. So that's another technique that we've covered in this session as a way of looking at data that's stored in a spreadsheet and avoiding that need to start converting it to ASCII. All right, on to the third and fourth section now, and this is something that is going to be in sort of 2 steps. And I'm going to actually take as I'm looking at the time here, as I've got through quite a bit of time already, I'm going to look at working with figures in reports, and I'm actually just going to pull up some files here that are already been made, rather than take you through setting this one up, I'm afraid. But you can have the scripts, of course, afterwards for all these things. All right, so what I'm setting up here is a very standard simple run. What we've got in this data file, again, fairly simple data. We've got, in here, we've got a serial number. Then we've got whether they're aware of 5 brands, which are denoted by ones and blanks. So they're in the next block of fields. Then we've got whether, just go back to the STP file. We can look at it here, can't we? If we look at the script, let's open up the script. Here we go. So here we go. So we've got the region in the 4th field. In 5 to 11, we've got some brands, and then we've got some rating of some other brands here, which you can see are called brand 101 to 105, which are in the next block of fields. And we've also converting this to an integer, which I'm going to talk about in a second. So a very simple questionnaire: region, some awareness of brands or favorite brands, and then some rating of some other brands, 5 of them, which we're calling brand 101 to brand 105. And if we just run this, we can see some tables coming out. They're not excitingly exceptional tables. So 40 records here, 7 brands down the first, cross-analysed by 4 regions, and then some rating scales here, which are all pretty standard stuff for brand 101, 102, 103, 104, 105. And then a sort of top 2 box analysis here for those that rated brand 101 as very good or quite good, down to brand 105. And then finally, a mean score summary table. Now, the typical way of handling that mean score summary table would be to do some plus T tables, perhaps, and put them one underneath the other. And that's a perfectly good way of working. There's nothing wrong with that. But the reason I'm not going to do that here is this section's going to, or this little bit of the section is going to be looking at how you can take figures from tables and automate them into Excel and PowerPoint or other types of reports that you want, and how you can actually get at the figures within MRDCL to perhaps do some calculations, or perhaps even to hide some data, some of the tricks that you can do to get into the data. So what I've done for table 8, which is the mean score summary table, rather than do it as a series of plus T tables, so conventionally you might have gone table 8 is brand 10 underscore 101 times dollar region, and you might have put an endis on that so that you get no mean scores. Put a percentage AVG in there so it says product 101, and then we could just copy that and paste it and do product 102, put a plus on the front, give it a different table name, and it would do what we want. So let's just do that, shall we? Let's call that AB and BB. Let's just do that, and we'll have the mean scores for the first 2 brands. Obviously, I haven't been put in for brands 103, 104, 105. I've got a table which has got a mean score done the conventional way, and you can see it does match the table that I've got below, except it's got only 1 decimal place. So that's the conventional way of doing mean score tables. But the problem with that is it doesn't give you much access to the numbers. It's hard to manipulate that or pick up those figures and do anything with them later. So I'm going to delete those 4 lines and look at the alternative way of doing them. And the first thing I'm doing is here in an integer, I'm converting the values in the variable here to an integer values. And what I'm saying is define brand 101 to 105 as an integer with an I on the front here, defining as an integer, setting the values so that very good gets 5, quite good gets 4, neither good nor poor gets 3, down to 2 and 1. And then the score for my brand is then stored in an integer. What that means is I can now do my table by having two tables manipulated. So my first table here is going to be a sum of the scores, and the second table is going to be the people that gave those scores, so that I can divide one other by the other and have one table, table 8, that contains everything, rather than 5 tables that are plus T one underneath the other that become difficult or impossible to manipulate. So I've now got a table where table 8 is dummy defined. It's dummy defined as the 5 brands, and if I comment that out just temporarily, what you'll see it has given me is an empty table, but the shape of the table I want. So it's given me the table that I want. It's given me the 5 brands. It's given me the regions across the top. If I now enable this line of code, you'll see that it's weighting each line by a quantity weight of that score in the integer, which was 5, 4, 3, 2, or 1, for each row of the table, for row 1, 2, 3, 4, and 5. And this table 8x here is going to store the number of people answering. So I'll just take that off and I'll hide this code, then I can show this in action. So now I've got a table 8, which is the sum of my score. So these are the sum of the scores from my respondents. These are the number of people, and it happens to be everybody in each one here, but it could be different numbers for each brand. And so what I want to do is divide this table by that table to get my mean scores, just like you would in a normal mean score table. And I was just preventing that because I commented out those lines, and now I'm dividing table 8 by table 8x, and I should get now my mean score table. Here it is, and now I've got my mean score table. Now that's more useful to me for manipulation purposes, because it now means I can pick up those figures and put them through to other runs. And just to show you the sorts of things that you can do, let's do something on table 1 here. So look at table 1. Let's say we wanted to hide any column that had a total of less than 10. So East, we want to hide the data in East because any base is less than 10 we don't want to show. So what I want to do in this example is I'm going to pick up that figure there, and I'm going to hide any column that happens to be less than 10. So let's do that, and let's just look at how we do that in Manip, because it's then an intro to how you can pick up figures in Manip. Now this might look unusual code to you, but this is all perfectly valid. I can say that I want to pick up in an integer, let's call it base, the number of people in table 1, row 0, column A. So what I'm doing here is I'm actually defining an integer. You can define variables in the Manip stage. A lot of people just don't know that. And I'm going to define it as the value in row 0, column 1. And then I'm going to say, if that base is less than 10, what I want to do is actually take table 1 and set it to 0.0. So what it's going to do then, it's going to set the whole of that column to 0 if, I've actually already opened the loop, it's going to set the whole of that column to 0 if the base is less than 10. So let's run it now. Let's have a look what's happened. And sure enough, East has now been blanked out because I've said if the base is less than 10, I want to get rid of the data. And of course, I can use that technique with something like BCS. So if we go to our tables and say format equals BCS, it will now actually hide the East data completely because I've set that column to 0. What this is demonstrating is that you can get at the figures in the tables if you want to, and you can do tests on the tables, or you can just pick them up. And indeed, if I wanted to, I could list that data out to a CSV file. I could say something like list CSV table 1 row 0, column A equals and dollar base. So I could actually list that data out either using a list statement or a list CSV statement. So if I do that, what I'm getting out now, if we go to the standard run report.csv file, is I'm getting a little report in a CSV file of something about it. So it's telling me that in here, table 1, row 0, column 1, there's my bases 10, 12, 7, and 11. So I can list this information out to a CSV file or just to an ordinary report file so that I've got that data that I can use somewhere else. Now this is why this is in two parts, this session. This is an intro to what you can do when you get to the next level, and you can start to automate some things in Excel from MRDCL. So I'm going to go now to a worksheet, a workbook called Control, and I'm now going to show you a completely different application of where this might work for you. So what I've got here is a workbook, and in this workbook I've just labeled these rows before I've got here as rows 1 to, or I've actually not done them properly, done 29 and 30, but they're called row 1 to 30, and I've called them columns. There's no limit to the size of this, just for convenience I've gone to 30 rows, and I think I went to about 20 columns. And in here you can see I've got some figures. So I've got some figures in here. They're random figures at the moment. And the reason I put in some random figures is I want to make a report based on these figures. And if we go to the report, you can see here's some charts that are linked to these figures in here. And of course, I could link these figures through to PowerPoint as well. There's nothing to stop me putting this object into PowerPoint so that everything is actually driven by this worksheet here called report data. Now my challenge is, wouldn't it be good if MRDCL could just output this for me so that all I need to do then is update this worksheet and my charts automatically update with the figures I've got in here and maybe a PowerPoint presentation that's on the back of it. All right, so that's the challenge. Now, the way that you can do that in MRDCL is that there is a generic script that I'm very happy to share with anybody that's written in EPS that will read controls that will output this information automatically for you exactly in the cells you want it. You can see I put these in just random cells in Excel here. This one starts in column 7, this one starts in column C, and so on. They're linked straight to these charts here. So my challenge is to get the figures out exactly like this from my run that I was doing just now. And you can see I've got the favorite brands, the rating of brand 101, the mean scores, and the top 2 boxes down here, so that I can just paste them in here and the charts will update, and that will be a report I send my client. And that could be multiple reports, of course, as well. The technique I'm doing for that is to have a mirror of this sheet here in here. And so all that I've done, I'm not going to do it because I'm sure I'll do it wrong, is I've actually just taken this data here, I've copied and pasted it into here. I've removed any text manually, so I've stripped off this text here, these labels here, and I've just left effectively the figures in here. And then what I'm going to replace it with in here is the cells that I want from my tables. So in here, I want table 1, row 1, column 1. In here, I want table 1, row 1, column 2, and so on, and down to row 7, and so on. And here I want table 2, here I want table 7, and here I want table 8. Now, I used an Excel trick to do this. I'm not an expert actually in functions in Excel. I'm much better at writing VBA, but there may be other ways of doing this. the way I got it so that I could just literally drag this cell down, I could just set up this one here. You can see at the top here, what I've done is I've said that that cell there is equal to #1 bracket row ampersand row A1. So that pulls in the 1 for me. Ampersand column A1, that pulls in the 1 for me again. Ampersand bracket. So it's quite tricky, that bit of syntax there. So you might want to copy that. But once you've got that in there, and I could just delete this now just to show you this in action to prove that I'm. So once you've got that in there, you can just drag that. Once you've got that syntax in, you can just drag it down for the 7 lines that you want and drag it across here for the 4 columns that you want, and it'll automatically do it. If you just left it like that, it wouldn't. If you just typed it in as #1 row 1 column 1, when you dragged it, it wouldn't do the adjacent cells. You'd have to go through and update each one, which of course is dangerous, which is why I'm using the function row A1 to get a 1 and column A1 to get the 1 there as well. All right, so that's my control worksheet. That's going to tell an MRDCL run what figures to pick up from my tables. And so effectively what we're doing here, if we go to my run.stp file, this just looks exactly like the run you saw just now, with a couple of tricks. One of the tricks is that it's not going to have the figures just as I want them, because if it picks up the figures from the tables, it won't get the percentages. So what it needs to do is it needs to have some extra things in it. So I'm going to copy this upper level. I'm not going to type it because I'll just guarantee I make a mistake with this one. I don't often cheat in these things, but I am today. So let's open this up and see what extra things I've done to achieve what I want. Well, I've had to recalculate my percentages so that I've used a technique. You have to see how many rows there are in the table, how many columns in the table, so the whole thing is automated. But I need to recalculate my percentages so that tables 1 to 7 are going to divide each row and replace the figures in my tables with the percentage. And then down here we have a generic piece of script, a bit like the loop that I wrote earlier, using DB loop to pick up data from Excel. Here we have a generic script that's going to look at this worksheet here called data. It's going to look at this worksheet data and list out the fields that I want. And where it's blank, it's going to list out a blank for me. So it's going to actually output a blank to the CSV file that it's going to generate. And that's just a generic piece of script. And you can see I'm doing that by picking up the value in each of the cells, rather like I did earlier, listing it out. If it's blank, it's going to put out a blank. If it's not blank, it's going to put out the value, rather like the way that we listed out some values just now. And if it's blank, it's just going to put a blank out for me. So what we're going to do then is run this script. And this is just a generic script. You can use this on any project. And sure enough, what that's going to do for me in run report.csv, if it opens it, it's given me the figures that I want in my report. So here's my data that I want in my charts, which means now I can just copy that and I can paste it into my report data, making sure that I start here because that's the first thing. And if I click on paste special, whoops, I missed that. And click paste special down here. I want to skip any blank cells. I don't want to touch any blank cells. Click OK. And now directly from MRDCL, based on what it's got in here, I've now managed to get all the figures exactly in the cells that I want, so that when I click to charts, I've now got a chart exactly as I want it, with all those things absolutely perfectly updated, which again could be pushed through to PowerPoint. So that's a very powerful tool. It uses generic scripts. You don't need to even learn how to do that. And of course, we'll be distributing these scripts afterwards so that you can do it for yourself. But that's a way where, by just having a workbook like this, that you will set up dummy charts here, or set up some dummy figures in here, put the figures anywhere you like, set up the charts based on the dummy figures, generate this worksheet here that tells it where it's getting it from. Then you can run my generic script called run.stp, which will magically allow you to paste those figures into the report, and you've got a set of charts in Excel or fed through to Word or PowerPoint automatically. A really powerful tool. I've overrun by 2 minutes. I'm going to take questions for about 10 minutes so that we finish in about 10 minutes time. That's the end of what I've got today. I hope that was all useful to you. We touched on a number of different techniques. What I tried to do there really was open you up to some ideas that you may not have seen, may not be aware that you can even do in MRDCL. So over to Charlotte. Have we got any questions that have come in that I can try and answer in the 10 minutes we've got for any questions?
Hi there, yep, we do. Thanks for that, by the way, Phil. So we've got a few that's come in, so I'll work through them.
Okay.
The first one I've got is there any limit to the number of data files you can have?
No, I assume you're talking about the first demonstration where we looked at multiple data files. If there is a limit, I don't know what it is, but I've used hundreds. So I think I'll say no unless anybody proves me otherwise. I don't think there's any limit. You can just have as many as you want using those techniques I showed at the beginning when I had to use 4.
Okay, thank you. The next question I've got is, can you mix ASCII and binary files in the same run?
That's not such an easy question. You would need to what I would do if you want that is that you would need to convert your ASCII file to binary so that everything was binary. You couldn't convert all your binary to ASCII because you'd lose multi-codes and so on, or you'd corrupt the data. But you could convert all your ASCII to binary, and which is a very short script. You just read it in and punch it back out again as binary, and then you could read all the files as binary. Otherwise, you couldn't mix them together. If the person asking that question wants to send me an email, I'll explain that in a bit more detail and give an example. But yes, you would need to convert the ASCII to binary basically, and then read it all as binary.
Okay, thank you. And can you make, oh no, just done that one. Can you set up MRDCL to carry out several runs one after the other?
If I understand that question correctly, rather than running as I was there, I think at the beginning the USA 2017, then the USA 2018, and then China 2017, then the total run. You want to be able to do all of them one after the other. You can set up batch files in MRDCL so that you click on a batch file in Windows so that it will kick off one run after the other consecutively. I can't cover that in this session here. In fact, it's actually a good topic for a video, and what we'll do is we'll add a video to our lists that shows you how to set up batch files so that you can put as many runs in you like that run them one after the other. But what I've shown you today doesn't do that, I'm afraid. But there is a technique for doing it within Windows by setting up a .bat file, but you need to know how to do that.
All right, thank you. We've got, could you read CSV data in the same way as Excel data?
No, I think you're referring to when I read directly from Excel. No, you can't. You would need to convert the CSV to an Excel file. There are tools to read from CSV files in MRDCL, but it hasn't got the same power. I mean, CSV files are used for lists predominantly in MRDCL. It hasn't got the same power that Excel has when you use EPS. You could in theory, but I think you'll need some of the tools that Excel offers. So given the fact it's just a save as Excel, I would treat it as Excel every time.
And I've got, is there a manual to use EPS?
No, there's not. we've learned over the years that documenting what EPS can do is not a good way of learning EPS, because, for example, EPS has been used to make these charts here effectively. If the EPS didn't exist, you wouldn't be able to do what I'm showing you on the screen now. And EPS in a manual form totally understates what it's capable of. As a result of that, we've produced a series, I think, of 7 videos that take you through the fundamentals of EPS, but not more importantly, why EPS might help you and what it can do for you. So there's a full tutorial there of 7 videos. I think one of the videos lasts about an hour because it really goes into depth as to in how it might help you and what it means that you can automate. So I don't think the manual is the right tool for EPS. I mean, the help within the program gives you the syntax, but that doesn't really tell you where it might be beneficial to you, because there are so many applications. And really, I think to get the full benefit of EPS, I'm sounding a bit like a bit as I'm preaching a bit now, you really have to immerse yourself in it to the extent that you have to see what its capabilities are and understand that, and then explore that further and to how you might deploy it. And the videos really do go into that depth. So I would commend you to the videos if you want to learn EPS and see where it really can help you. Another question, Charlotte?
It says, how did you paste the results into Excel without overwriting the cells already there?
Well, of course, I charge a fortune for training courses in Excel. Can I undo that? Yes, I can. Okay, it's quite an easy technique. There may be other ways of doing it, but you basically grab the figures. Oh no, I've lost the figures now. Let's go to the other run. Where did I have them? Here they are. So here's the figures we wanted to paste in. I still got them, I think. So I copied them here. I went to the report data. I positioned myself at that cell there, which is where the data is coming from. I used paste special, but I used a trick which is not widely known. And if you go down the bottom here, there's one that says skip blank. So what it will, if I just left it and clicked OK now, all of the text like favorite brands and brand A would get overwritten, and consequently in your charts they would all disappear. So there's a checkbox down the bottom here that says skip blanks, which means that what you're pasting from only overwrites the cells you've got something in. And of course, what we've carefully done here is only output to our CSV file these figures here, so that when I click OK now, it only overwrites those cells, those cells, those cells here, and those cells there. And now, hopefully, my PowerPoint looks spot on. So yeah, bit of Excel training for you there, but that's free on this occasion. Any more?
There's just one more here.
Yep.
It says, are all variable types allowed in the manip stage? Could you pass variables in the manip stage to another run as an IDF?
Difficult question. Yes, all variable types are available. The second part, can you pass it to an IDF? No, you can't, but you can pass a tables file into another data stage. So you can say, I want to ITF in a table into another data stage, such that then you could write variables that picked up from those tables that you'd pushed into another data stage. I don't know if I explained that very well. It means that you can have lookup tables effectively, that then you can look up figures from another set of tables. So yeah, if you want that, please write to us and ask us, and we'll help you with that. But yes, you can't send variables in the manip stage. It's too late. No, let's not go into it further. You can take tables into another data stage, so that then you can write the variables to pick them up, doing what I think you were probably trying to do. Did you say it was the last question?
That's everything for today. Yeah, that's all we've got coming in.
All right, well, I'll leave you to close out then, Charlotte.
Okay, but if anyone else does have any more questions, we're happy. Just send me an email and we can get back to you. We've recorded this session, so I'll send you out sort of tomorrow the recording, so you can watch it back if you want to. But thanks for everyone's time, and we'll say goodbye for now.
Goodbye.
Goodbye.
Bye.